All right, so this video is going to walk you through the steps and how to create your dilation project. And you will see that I have created a very boring shape on a coordinate plane. If you don't have a printer, you can just use a piece of grid paper and create your own coordinate plane. You'll also notice you only need the first quadrant because we're only going to be dealing with positive numbers. All right, so the first thing I did was I created a list of the ordered pairs after creating my diagram. I then created a list of the ordered pairs. I'm going to do that real quick and I'll be right back. All right, I created my list of ordered pairs. And so now the next thing we're going to do is we are going to dilate the shape that I created, but we're going to dilate with a scale factor of 2. So I am going to take all of these coordinates and I'm going to multiply both the x and the y value by 2. So 1420 becomes 2840 and 1215 becomes 2430. 24. D is 2416. E prime will be 2822. 18 will be 3624. And 14 becomes 2828. All right, let's go ahead and graph those and see what happens. So we're going to go 2840, 28, and we're going to go all the way up to 40. Got to keep going all the way up here. Then that is A prime. Go ahead and label your points as we go. 2430. That's going to be B prime. 24, 20, 24. This is C prime. 2416. I went too far. Here we go. 2416. That's going to be D prime. E prime will be 2822. 28, 22, and 3624. 36 actually goes off the grid a little bit. Oops. I'm going to estimate because it only goes to 35 to 24, goes up to here, and then 2828. All right, now I'm going to take my straight edge and go ahead and I'm going to actually use a different color just so that they stand out a little bit more. Then this one comes over to here. All right, so now we have these points. Now, so we have this dilation. Let's think about how are they the same and how are they different? So clearly one's bigger than the other. So the size changed. What I want you to think about though is what didn't change. So the side lengths obviously got longer because they are bigger. I have a tracing of the pre-image. So I'm going to go ahead and put it on the dilation, and you can see that angle A is exactly the same size, Angle B is the same size. C and D are both the same size. E is still the same size. F and G. So the angle measures stayed exactly the same. The only thing that got bigger was the length of the side. So now we're going to do the same thing, but we are going to dilate our shape, the original shape, by a scale factor of 1/2. So we're going to take all of these coordinates, and we're going to multiply them by 1/2. I'm going to pause the camera and do that real quick, and I'll be right back. Okay, so now you can see that all I've done is taken each coordinate. The A was at 1420, so I multiplied 14 by 1/2 and got 7. And same thing with 20 to get 10. So you take half of the number. So now let's go ahead and graph these and see what happens to our shape. So the first coordinate A double prime is 7, 10. B double prime is 6, 7.5. 6, 7.5. C double prime, B double prime, A double prime. C is 5, 6. D is 6, 4. E is 7, 5.5. F is 9, 6. F double prime, and G double prime is 7, 7. Now we can take the exact same now we have the exact same shape, it's just at a scale factor of 1/2. So let's take this original tracing again and line it up on those angles one more time. We can see that all of the angles again have stayed the same. The angles are consistent. They have not changed. The only thing that changed was the side length. Okay? Now, we will do it one more time, but this time we're going to multiply by a scale factor of 1/4. So we're going to go back to our original coordinates and take 1/4 of each of these numbers and create another set of values. Okay, again, I have created ordered pairs by multiplying each of these by 1/4. So let's go ahead and plot those and see what happens. I'm going to scoot the paper over a little bit, make sure you can see. So we're going to go, the first one is 3.5, 5 over 3.5, up 5. That's A triple prime, excuse me. 3 and 3/4, 3 and 3/4, 2.5 and 3. And D is 3, 2, D prime, triple prime, C triple prime, B triple prime. E is 3.5 and 2 and 3/4. And F is 4.5, 3. And G triple prime is 3.5, 3.5. Now, this is exactly what you're doing when you, on the computer, when you have an image and you drag it from the corner to make it larger or make it smaller, you're changing all the dimensions, but the one thing you're not changing is the angle measure. So the size changes and the angles measures don't. You still have right angles. So again, we can see that our angle measures have all stayed the same. So we have created three dilations from our pre-image. And let's think about what changed. So what changed? The size changed. Did the orientation change? We'll see what didn't change. What didn't change was the orientation. A is always at the top, D is always at the bottom, C is on the left, and F is on the right. So the orientation stayed the same. The actual shape stayed the same. What changed about it? The side length. We noticed that, what about the angle measures? So the angle measures did not change. And but other than the position also changed, because rather than being here, it's over here. So the position, or where it's located in space, does change. Okay? We call these shapes that are the same shape but a different size, we say that they are similar. That's a word that we use in the English language a lot. So but in math, it has a very specific meaning. We can say that that people are similar, or other things are similar, or someone's outfit might be similar. But in math, it has a very specific meaning. Similar in math means that that two different shapes are the same shape, and the only thing that's different about them is the size of that shape. So that is an important vocabulary word for us to keep in mind. All right, I can't wait to see your projects.